Welcome to this tutorial video. In this video we're looking at transition matrices. Transition matrices are used to describe the way in which transitions are made between two states. For example, if it rains today, what's the likelihood it will rain tomorrow? Or, if I read the Herald Sun this weekend, what's the likelihood that I'll read The Age next weekend? Or likely again, if I shop at Safeway for my weekly groceries, what's the likelihood that I'll shop at Coles next week for my weekly groceries? Our example is, students have the choice of doing either maths or English during their study periods. 80% of students who do maths during one study period will do maths the next study period. And 30% of students who do English during one study period will do English the next study period. We look to examine three ways of representing this data: a transition table, a transition diagram, and a transition matrix. First of all, a transition table. Transition tables are set out as such, with transitions from at the top of the columns and transition to the left of the rows. So let's fill this in. First of all, 80% of students who do maths during one study period will do maths the next study period. So this is the transition from maths to maths of 0.8. That leaves us with 20% or 0.2 as a decimal of students who transition from maths into the English tutorial group the next time they study. Likewise, 30% of students who do English will do English the next study period. The transition that complements that is that the remaining 70% who do English in one study period will transition to maths for the next study period. We can check that both columns add up to a total of 1, representing 100%, which they do. Likewise, this information can be represented with a transition diagram. First up, we can state that of those students who study maths during a study period, 80% of them will transition into maths for the next study period, or remain in maths. That means that 20% of students who study maths will transition into the English study the next period. English has 30% of students who study English during one study period will do English the next study period, and the remaining 70 who study English will transition into the maths study group the next period. Finally, the transition matrix. 80% from maths to maths, remaining 20% from maths to English. 30% from English to English, the remaining 70% from English to maths. Comparing all three, you can see the similarities. The transition matrix is exactly the same elements as the transition table without the column and row headings. Let's apply this data. Given that initially there are 60 students studying maths and 40 studying English, 1, we need to calculate the initial state matrix. 2, we need the number of students in each study class for the next subsequent 3 study periods. And 3, we need to calculate the long-term, or what we call the steady state matrix for this scenario. An initial state matrix, S for state matrix and 0 for the initial. It's at the beginning, is a column matrix where the first row represents the 60 students studying maths and the second row the 40 students studying English. Now they're in the same order vertically within that particular column as was the matrix, transition matrix, and the transition table. That is, maths was the top row and English was the second. That order is important. Let's calculate the number of students in each study class for the next study period. The one study period down the track. And that's simply done by multiplying the transition matrix by the initial state. Here's our transition matrix, and here's our initial state. 60 in the maths, studying maths, and 40 studying English. Using our CAS calculator, our TI Inspire, we come out with an answer of 76 students will transition into the maths class, and only 24 will remain in the English class after one study period ahead of the initial arrangement. Likewise, we can work out the state after 2 study periods, remembering that one study period was really the transition multiplied by the initial state, as we have here. the transition by the initial state. So to work out state 2, we can multiply the two transitions and have transition squared multiplied by the initial state. So here's our transition matrix, squared, multiplied by the initial state, the initial 60 studying maths and 40 studying English. Multiply them together and we can see that after 2 subsequent study periods, there are 77.6, or roughly 78 students in the maths class, or studying maths rather, and 22.4, roughly 22 students that will be studying English during the study periods. Likewise, for the third state, the third subsequent study period, we can take the transition matrix and multiply it by the initial state. This gives us again 77.76 and 22.24 in the respective classes. You can notice the difference from the previous week is not great, just a small increase, which leads us to our final calculation, that is to calculate the steady state, or what we call the long-term matrix. Now we've reached the steady state when 2 subsequent states result in the same matrix. We were getting there before with state 2 and state 3, they were very similar. Typically, to check for steady state, I recommend you go to state 50 and state 51. They're a long way down in terms of long-term states. So to find state 50, we take the transition and we raise the power of 50 and multiply it by the initial state. This gives us an end matrix of 77.78 and 22.22. Likewise, to find the 51st state, we take the transition, we raise the power of 51, multiply it by the initial state. That also gives me 77.78 and 22.22. These 2 subsequent states, the 50th and the 51st, produce exactly the same resultant matrix. So we can say that a steady state matrix has been reached. And long term, the number of students in the maths class, or those students studying maths during their private studies, is 78 students. And it can be said long term, the number of students studying English is 22 students. I hope this assists people with transition matrices and steady state matrices. Thanks for viewing.